Hello, everyone. I'm Instructor Mary, and I'll be taking us another topic, which is law of indices. We have our interactive content here that will serve as a guide for this class. When we are talking about indices, we are talking about power of numbers. So indices is reversed to as power to which a number is being raised. So if you look at this picture we have here, this is just like we are having a number and n is serving as the index number. That is the power at which x is being raised. So we refer to x as base number, while we refers to the power at which x is being raised as index number. Now we have some rules that guide us whenever we are solving any given problem under indices. The first rule is telling us that if you have a raised to power m multiplied by a raised to power n, then we can solve it by taking a as a common term and adding the powers, which is m plus n. Then if we have a raised to power m divided by a raised to power n, then we take the common base number, which is a, then we have the power to be m minus n. So that implies that whenever we are having indices, our plus changes to multiplication and vice versa, addition changes to minus and vice versa. So if we have this rule, have a base number and an index number of this form, a raised to power m into brackets or n, then we multiply these powers that we have, and we have a multiplied by n as it's being expressed here. Anything raised to power 1, is just like we're having a multiplied by 1 or a in 1 places, so it will give us a. Anything raised to power 0 will give us 1. So, and we have another rule here. When we have a over b into bracket m, then we can split this to what? A raised to power m and b raised to power m. A raised to power minus m, if you want to re-express it, this is just like we're having a fraction form. This sign is a shortened fraction of 1, so it's going to be 1 raised to power a 1 over a raised to power m. Then when we have a, which is the base number, raised to power x over y, then this can be expressed at root y into a raised to power x. So we have a given illustration here which serve as examples to those rules that we have. So now let's look at these activities based on our explanation. Now, if you have 5 raised to power 4, 5 is what? 5 is the base number and 4 is the index number. So the index of 5 raised to power 4 will give us what? It will give us 4. Let's check. Now we have that. Now let's look at this expression. This is x and this is n. X will serve as what? This should serve as our base number and index number is n. So index number is n. Let's check. Let's see what we have. So we are actually correct. Now that leads us to the next rules. These are positive rules of indices. As I made mention of it earlier, when you have a common base number, then you pick it as 1 and you add up the powers. So m raised to power m multiplied by a raised to power n will give us a into m raised plus n. Now when you have a raised to power m divided by a raised to power n, then this division sign changes. Base number is common, so we pick one of it, then we have m minus n. Then when you have a raised to power m in bracket of n, we have to multiply the powers, because if you look at them, both of them are powers, so we multiply the powers together and that gives us a raised to power m times n. Now give us, let's look at this. This is the negative law of indices. If you look at this, this is just like we are having an expression of a fraction with a base number a. So if you want to rewrite this, it's going to be root n into a. So it's going to be root n a or a root n. That of the way we are right. So if you have m raised to power n over m, then if you have to express it, it's going to be what? Root n into a, everything raised to power m, or you have it as a root m raised to power n. So we can have that, or we can even have it in this form: a raised to power m root n. So that's how we express that. Now that will lead us to some activities that we can do. Okay, before then we still have what we are called zero index. This one is telling us that when you have zero indices, anything that is raised to the power of zero will give us 1. That is a law under indices. So anytime you have any base number raised to power of 0, then definitely you just know that the answer is 1. Now that leads us to, we have an activities here that we're going to be doing together, and we're going to be checking the results to see how good we are and to know if we are actually right. So let's check through and let's see. Okay, so if you look at this, we have 2 raised to power x equals to 32. Now if you want to solve this, you have to look at the base number that is common. So you have to find the base number of 2 here. Now how many times can you multiply 2 to give us 32? I believe that should be what? That should be 5 times. So it's going to be 2 times 2 times 2 times 2 times 2 in 5 places. So by the time you multiply 2 in 5 places, it will give us what? 32. So with that, we can rewrite 32 as 2 raised to power 5. That is, we are multiplying 2 in 5 places, it gives us what? 32. If you look at this, we have a common base number which is 2, so we cancel out our common base number and our s equals to 5. So for this question, s is going to be 5. Now we are going to be doing the activities based on the solution that we have been given, which is what? X equals to 5. So let's try and rearrange the activities. Let's drag the correct value into it and let's see what we have. So now for this one, it's going to be what? We are having what? That is 32, because 32, by the time it's we multiply it in 2 places, express it in 2 raised to power 5 will give us what? 32. Now by the time we have solved based on our solution, we cancel x here. Our x will now be equals to 5. So that give us solution to this problem, which is find the value of x if s raised to power s equals 32. So let's check we are right. So let's look at another. This is another exercise for us to do, which is find the value of m if 3 raised to power m minus 1 equals 81. So let's solve for this one. Now what we need to do is we calculate and look for the express this in the power of 3, because we have a base number here that is 3. So this one as well, we have to express this in the base number of 3. So how many times can we multiply 3 to give us 81? So let's solve. So let's look at the solution here. As I've actually said, we have 3 minus 1 equals to 81. 3 can be multiplied by 3 by 3 by 3 in 4 places to give us 81. So we express this at what? 3 raised to power m minus 1 equals to 3 raised to power 4. So because we have a common base, we cancel 3 and 3. Now the next value is what? We have m minus 1 equals to 4. Now from here, what I've done is, by the time you have any sign that want to cross the equals to sign, the sign changes. So if you have minus, it want to cross the equals to sign, it will change to plus. And if you have plus there, it want to cross the equals to sign, it will change to minus. So having that, we now have m equals to 4. Then this crosses the equals to sign, changes to plus. So we have 4 plus 1. So by the time we have 4 plus 1, 4 plus 1 will give us what? Will give us 5. So we have m equals to 5. So let's use this solution to drag the correct answer to the boxes we have there. So let's drag the correct answers. So for this one now, 81 is going to be expressed as 3 raised to power 4. And by the time we have 3 raised to power m minus 1, then 3 cancel 3. We have what left? M minus 1 equals 4. So we have m minus 1 equals 4. Now, it has crossed the other side. So 4 plus 1 will give us what? 4 plus 1 will give us 5. So we have 5 here as our final answer. So let's check. So we are right now. Let's go to the next slide and see what we have. We have past questions here for us to solve. We are going to be solving this together. This is a raised to power 8 divided by a raised to power p equals a raised to power 2. If you look at it, we have a common base of what? Base number of what? Of a. And I have said earlier that any lord of indices that has to do with signs of divisions and multiplication. The sign changes. So for this division now, the sign will change to what? It will change to minus, and we have a common what? We have a common base number. So let's solve together and see what we have as our final answer. So let's solve it and let's see. Okay, so we have we are going to be having 8 minus b. Since we have a common base, so we pick one of them, a raised to power 2. So as we have done earlier, a will cancel a, it is a common base, so it cancel each other. So it's going to be a minus b equals to 2. Now let's collect the like times. Let's leave our minus p here. I've told us that whenever we have a sign and want to cross the equals to sign, it changes. So this is plus 8. By the time it crosses the equals to sign, it will change to what? It will change to minus 8. So it's going to be what? 8 minus p equals to 2 minus, what do we have here? We have 2 minus 8. So we have 2 minus 8. Now since we have 2 minus 8, so it's going to be what? Minus p equals to 2 minus 8 is what? What will it give us? That is minus 6. So 2 minus 8 is minus 6. Since we have minus and minus, it can cancel each other. So this cancel this. Our p is going to give us what? P is going to give us 6, and 6 is the final answer for that. We have another past question here we are going to be solving together. Let's pick the first one, a, which is 3 raised to power minus 2. Based on the rules that we have, that whenever we have a minus m, it can be written as what? 1 over a raised to power m. So that's the rule that we are going to be using for this question. So for this one, we can rewrite 3 minus raised to power minus 2 as 1 over 3 raised to power 2. So what is 1 over 3 raised to power 2? That is 1 over 3 raised to power 2 is what? That is 3 in 2 places. 3 times 3 will give us 9, and that's going to be the answer for this. Let's look at this one. We have a rule that says that y over m will give us what? N root a raised to power y. So that's what we are going to be doing here. Now let's rearrange this one. If you look at this number that we are being given, this is a mixed fraction. So let's change to proper fraction first, and let's see. 9 times 1 will give us what? 9 times 1 is what? 9. Add 9 to 7, that is 16. So we have 16 over 9. Remember, we have half. So if we are changing it, it's going to be what? Root. We are going to be root 16 over 9. Now, if you have root 16 over 9, what is root 16 over 9? That is what? That is square root of 16 is what? 4. That is 4 times 4, right? Now, square root of 9 is what? 3. So we have 3. Now, let's change this to mixed fraction. How many times can 3 goes in 4? We have 1. It will remain what? 1. So we have 1 over 3. So, and that's the answer for the two question we have here. So we are going to be dragging the solution here and see how we can actually have the final answer based on the activities we have here. So let's drag. Let's drag and let's see the solution. So for this now, our answer is going to be what? 1 over 9. And now for this, by the time you change this one to a improper fraction, it's going to be 16 over 9. The square root of 16 is 4. The square root of 9 is what? 3. So we have 4 over 3. And that's the answer. So that's the answer. So this takes us to the end of this class. We want you to subscribe to our channel for the full details of this interactive book, and it will really be of help for you to study further, which as our website is www.edubbey.com. Thanks for listening.